we are. Maybe you are sitting watching the snow outside your window and you've already been sledding and built your snowman and had your snowball fights. And maybe you are just sitting and there's no snow outside. Who knows? But here we go. Regardless, these are our pre-10b notes on how to simplify a complex fraction. What is a complex fraction? Well, it's a large fraction which has smaller fractions inside of it. We're going to call those smaller fractions inner fractions. To simplify a complex fraction, we're going to eliminate the denominators of those inner fractions, right? Which gives us simply one fraction with no inner fractions, and then we're going to work on reducing that. So, the key to fractions is always factoring, and our first step is to factor each inner denominator. So I'm going to take my fraction, right? This is my big fraction bar, and inside of it I have two smaller fractions, one here and then one here. So I'm going to come in and I'm going to rewrite this, and I have 3 minus 7 over x plus 2, which is prime. That doesn't factor anymore, but if that were, say, x squared minus 4, I would factor it to x plus 2 times x minus 2. And then on the bottom I have 1 over x minus 3, which again is prime. So my inner denominators, x plus 2 and x minus 3, are both factored. My second step is to determine the LCD of all those inner denominators. So my LCD should contain all the factors of each denominator. So my first denominator has the factor of x plus 2. So that's going to go into my LCD. My second denominator doesn't have x plus 2, but it has x minus 3. So that's going to be part of my LCD. If I had common factors, so if I had an x plus 2 squared, right, on top, and I had an x plus 2 on the bottom, I would take the highest power of that common factor, like we did when we add and subtract. Okay, now we are going to multiply top and bottom of the large fraction by the LCD. So I'm going to come in here, and I'm going to take this numerator, and I'm going to multiply the top of the big fraction by what I determined to be my LCD. So I'm going to multiply it by x plus 2 and by x minus 3. And then I'm going to take the bottom of my big fraction, and I am also going to multiply that by x plus 2 and x minus 3. So in effect, in multiplying by this second fraction, I am multiplying by 1. Now when I multiply, I'm going to come in here and I'm going to distribute both of these factors across my subtraction. So when I do that, I get my 3 times the x plus 2 and the x minus 3. And then I get minus, and then I get my fraction 7 over x plus 2. And that fraction gets multiplied by x plus 2 and x minus 3. Now, I have my big fraction bar, okay, that's from this here, multiplied by this here. And I'm now going to take these factors and distribute them across this subtraction. So that gives me the 1 times the x plus 2 and the x minus 3, then minus this one here. So this, well, this one, give myself a little more room. Minus my fraction, which is 1 over x minus 3, times my factors x plus 2 and x minus 3. So when I do that multiplication, following my order of operations, right, we do multiplication first. So I'm going to multiply these together, which is going to give me 3. Right? Foiling those, I get x squared minus x minus 6 minus. Now the whole reason I multiplied over here was so we could divide out that denominator. Right? X plus 2 divided by x plus 2 is 1, which leaves me now the 7 times the x minus 3. In the denominator, we're going to multiply these together. Foiling those gives us x squared minus x minus 6 minus, on this side, we're going to divide out, no, sorry. I'm going to leave that. We're going to divide out the x minus 3 with the x minus 3, which gives me x plus 2, right? So we weren't dividing out this x plus 2. That is still there. Okay. So we've eliminated our inner denominators, right? And we have done, if we follow the steps, we've actually distributed that LCD, right? We've divided out our common factors from each product. And now we're going to simplify the resulting numerator and denominator of the large fraction. So I'm going to come in here, we're taking this up here, and I'm going to simplify this numerator. So that gives me 3x squared minus 3x minus 18. I've just distributed this 3, minus 7x plus 21. I've distributed this negative 7 here. And that is over, right? On the bottom, we have our x squared minus x minus 6, and now distributing this negative, we get minus x minus 2. Right? That leaves us, right, adding like terms with our 3x squared, that's this one, then our minus 3x and minus 7x, so that's minus 10x. And then our minus 18 plus 21 is plus 3 over, right, our x squared, and then our minus x and minus x, so that's minus 2x, and then our minus 6 and minus 2, so that's minus 8. Our next step is to factor our numerator and denominator. So if we come in here, right, I'll do this down here, we have our numerator, which would factor as 3x and x, and then if I do minus 3 and minus 1, then I think that gives me negative 9x minus 1x is 10x plus 3, that works. And in the bottom, this would be x and x, and I have a minus 8, so if I make that minus 4 plus 2, I think that works. I would love to see some of those factors divide out. They don't, so this is my answer, right, of my simplified complex fraction in factored form. Okay. Let's do another one. So here I have an example that actually doesn't look like a complex fraction, but if we apply the meaning of our negative exponents, I can rewrite this as 1 over a squared minus 1 over b squared all over 1 over a minus 1 over b. Now be careful, because these powers with negative exponents are connected through subtraction, I can't just move what's on top to the bottom and what's on the bottom to the top, because it's not just a simple fraction. Okay, our next step is to factor each denominator, right? And each denominator is fully factored, so there's no additional step there. And then we're to determine the LCD, and our LCD will contain a squared, which comes from our first denominator, will contain b squared, and when we take a squared, we already have an a and we have a b, so that's our LCD. Our next step, so we've done this, our next step is to multiply top and bottom by that LCD. So I'm going to come in here and I'm going to multiply the top by a squared b squared, and I'm going to multiply the bottom by a squared b squared. So when we do that, we're going to have to distribute that across the subtraction, right, both top and bottom. So that gives me, bring this down here, so that will give me 1 over a squared times a squared b squared minus 1 over b squared times a squared b squared all over 1 over a times a squared b squared minus 1 over b times a squared b squared. Multiplying each of those, here my a squareds divide out, and that leaves me b squared, minus, here my b squareds divide out, and that leaves me a squared, all over, here one of the a's divide out, leaving me a times b squared, minus one of my b's divide out, leaving me a squared b. So we've distributed our LCD, and that kind of takes us up to this step where we're going to simplify, actually, which is already done. So that takes us to 15. We're going to factor the numerator and denominator. So I'm going to take this to here. B squared minus a squared factors to b minus a times b plus a. In the bottom, I have a GCF of AB. So if I factor in AB, that leaves me b minus a. B minus a is now a common factor between the top and the bottom. I divide that out, and that leaves me with the fraction b plus a over ab. There are no more common factors, and that's our final answer. Okay. So as long as you follow the steps, no problem. Let's try another one more. So here I have 3 over x plus h squared minus 3 over x squared times h. Right? So each of my denominators are already factored. And so we're going to determine our LCD. Our LCD is going to contain all of what is in my first denominator, which is x plus h squared. That is different from having just an x, so I also need to take all my factors for my second denominator, which are x squared. In the bottom, there is no denominator, so we don't take anything for that. And now we're going to come in and we're going to multiply top and bottom by that LCD. So x plus h squared and x squared, top and bottom. Now we're going to take that and we're going to distribute it across the top, so over the subtraction, and then we're going to multiply the bottom by that as well. So when we do that, right, that gives us, bringing this down here, that gives us 3 over x plus h squared times an x plus h squared and an x squared minus 3 over x squared times an x plus h squared and an x squared. Right, all over our h times our x plus h squared and our x squared. Okay, the x plus h squareds will divide out as a result of our first multiplication, and the x squareds will divide out as a result of our second. So that leaves us with 3 times x squared, right, that came in here, minus 3 times x plus h squared, all over h times x plus h squared times x squared. We're going to simplify that resulting numerator. So we have our 3x squared minus our 3. If we square this x plus h squared, right, that's to multiply an x plus h times an x plus h, we get x squared plus 2xh plus h squared. And that's all over. Remember, we're going to leave this denominator in factored form. We're not going to multiply it back together. If we now distribute this negative 3 across these additions, we get 3x squared minus 3x squared, ooh, that's cool, minus 6xh minus 3h squared, all over our h, x plus h squared, and x squared. Okay, what was cool is 3x squareds divide out. Okay, that leaves us with this negative 6xh minus 3h squared. if we factor that numerator, then we can pull out a common factor of negative 3h, which leaves us 2x plus h over h times x plus h, which is squared, times x squared. We now have another common factor that shows up. This h can divide out with this h, and we are left with negative 3 times 2x plus h all over, I'm going to reorder this, x squared times x plus h squared. And we have simplified this complex fraction, right? And don't tell your friends, but you've actually done a very important part of calculus in that, which we'll add to a little bit later in the year. So that's it for complex fractions. Hope you have a great night. Whether I see you tomorrow or not, right, if you get your wishes come true and we have all this snow, then please continue with your work anyway. So love you guys, proud of you. Keep going after it. You can do it.